My name is Bryan O'Sullivan, and if you look out the window behind me, you'll see that it's nighttime, and that's because I'm giving this talk from San Francisco in California. And I'm here to talk about a revision control tool called Mercurial. More specifically, I'm interested in talking about a revision control extension on top of Mercurial that's called Mercurial Queues. And I'm here to talk about, even more specifically, managing a whole huge pile of patches using Mercurial Queues. So if you do software development against a third-party piece of software, you will pretty often need to make local modifications, or you'll want to develop a new feature, or something along those lines, and you'll want to do this as a patch. Now, in the Linux kernel community, some people have taken this to an extreme. They actually manage hundreds of patches at a time on top of the Linux kernel source tree. Now, the Linux kernel itself is about 20,000 files in size, and it contains about 220 megabytes of data. That's just a single snapshot of it. Now, record on top of that a whole pile of patches, and what do you get? Well, you get what I have on my laptop here. What I'm about to show you is a revision control operation that is pushing a whole pile of patches onto the Linux kernel. So why don't you watch some scrolling action go on while I do a little bit of talking here. Mercurial is written in Python, and even though it's written in Python, it's blazingly fast. One of the things that blazingly fast software lets you do is do new and interesting things. So, as a regular revision control user, you're used to committing your changes and updating your working directory and so on, but perhaps you're not used to having a floating pile of hundreds of patches at a time on top of whatever tree you're working in. Now, why might you want to do this? Well, what I'm pushing here is the patch series on top of Linux, and the patches contain experimental changes. They contain stuff that's going to go into the mainline tree fairly soon. It's essentially a dumping ground for a huge variety of different things, and it's a huge win to be able to maintain these as patches because you can develop them all independently and you can pull them all from different sources independently. Now, all of this stuff that you see scrolling past here is an individual patch being applied, and they show up as change sets in Mercurial's history. What this means is that once you have all of these patches applied, you can use regular revision control operations to actually work with them. So, you can use the annotate command to find out what patch changed a file. You can use the log command to find out what patches affected a directory. You can use the bisect command to binary search through all of your revisions, whether they're patches or regular old revisions in your tree. You can even merge between patches and revisions. This is pretty much the Swiss Army knife of revision control if you need to work with upstream third-party software, especially stuff that changes frequently. If you want to know how many patches I'm actually pushing here, I'm creating a stack of 1,738 patches. These patches are making 600,000 lines of changes, and this operation is going to complete in less than 3 minutes. It's pushing 7 patches every second onto the kernel source tree, and every single one of these I can edit whenever I want to. I can refresh. I can share those changes with other people. It is a tremendously useful thing. You should really go check out Mercurial Queues, and of course Mercurial itself is written in Python, so if you want to try it out, send in some patches, tell us how much you like using the software. That would be great. My email address is bos@serpentine.com, and I'd love to hear how well this stuff works out for you when you try it. It's tremendously easy to use. I hope you enjoy it. I hope it makes your life easier for developing and maintaining software. That's what we're interested in. Thank you very much. It's been a whole lot of fun giving this lightning talk from San Francisco. I wish I could be in Geneva. Maybe I'll manage it next time.